Okay, so here we have a typical question that asks you to calculate some masses using information from an equation. This is a slightly more difficult one, if for no other reason than this 2 here makes our life a little more difficult. So it says here, sodium carbonate is an important raw material and has many industrial and domestic uses. The equation below shows one of the reactions in the Solvay process, which converts sodium hydrogen carbonate into sodium carbonate. It tells us that 2 lots, or that could be 2 molecules or 2 moles of sodium hydrogen carbonate breaks down to create 1 mole of sodium carbonate, 1 mole of water, and 1 mole of carbon dioxide. Now the question says, use the equation to calculate the mass of sodium carbonate that could be obtained from 8.4 tons of sodium hydrogen carbonate. Okay, so the question involves the use of masses, okay, and it can also involve the use of moles, because these numbers here, which we could put the ones in front of there just to make it clear, we know there's a 1 there, these could be considered to be moles, and of course we could also use molar mass. So we're going to use some previous skills. We're going to use the formula triangle that we looked at earlier. So I'm going to move to a bigger piece of paper, as my writing is a bit big, and that's half normal size. So I'm just going to remind you of our formula triangle that we've seen previously. Okay, so in our formula triangle, we remember that we can put mass at the top. We can put the MR, that's the molar mass, or the molecular mass. They are the same thing numerically, and the number of moles. So we will be referring to this triangle shortly. So if we rewrite our equation, we saw in the question that 2 moles, or 2 molecules, we can consider them to be the same, of sodium hydrogen carbonate break down to form a mole of sodium carbonate, a mole of water, and a mole of carbon dioxide. Now, as far as this question is concerned, information that we need to take from here is that 2 moles of sodium hydrogen carbonate are required to make 1 mole of sodium carbonate. These 2 chemicals, for the purposes of this question, we don't need to worry about, because the question only mentions sodium hydrogen carbonate and sodium carbonate. Okay, so what we could do is we could introduce our triangle for the 2 compounds that we're interested in, and we could fill in the information that we know, or that we can work out, and then we can use that to work out what we need to know. So for the sodium hydrogen carbonate, we're told in the question that we have 8.4 tons. Okay, so the 8.4 is the mass, so that we can put up there. And what we need to know is how many moles of sodium hydrogen carbonate that 8.4 tons is. Okay, we know that the proportion of these 2 chemicals is 2 to 1, but we need to know how many moles there are. Okay, so to work out the number of moles, the number that would go there, we need to know the MR. Okay, now handily in the question, we are told the AR of all the relevant elements that we need. Okay, so to calculate the MR, which is the molar mass of sodium hydrogen carbonate, you'll notice that for this purpose, these purposes, I've ignored the big 2. We're just interested in the MR of the compound itself. Okay, then we need to add, I'll just put this underneath, so it's 23 for the sodium, okay, plus 1 for the hydrogen, plus 12 for the carbon, plus 3 times 16 for the oxygen, and that gives us an overall MR of 84 grams per mole. Okay, which is handy, because if we now put that 84 into this part of the triangle for the MR, and if we apply the triangle, we know that to use a triangle, If we want to know the unknown, we cover it up, and that gives us our calculation, which is 8.4 divided by 84, which gives us 0.1 moles. Okay. Now, I'm conveniently ignoring the fact that the question is in tons and not grams, but the maths works regardless. Okay, so we don't need to worry too much about that. So we now know that 8.4 tons of sodium hydrogen carbonate is the same as 0.1 moles. Okay, it's actually megamoles, but the number will remain the same. So now we need to be careful, because we need to transfer as much information as we can across here to finish the calculation off. Now we know from the equation that for every 2 moles of sodium hydrogen carbonate, we get 1 mole of sodium carbonate. Okay, so it's important to remember that. So in this corner of the triangle, we can now put the number of moles, but we must remember that it's half of that value, because 1 is half of that value. So we can now say that that's 0.05 moles. Okay, so for every 0.1 moles of sodium hydrogen carbonate we use, we will make 0.05 moles of sodium carbonate. And we can also add in the value to go in here by doing a similar calculation to the one we did before. So the MR of sodium carbonate, so this time it's 23 times 2, because 23 is the mass of sodium and there are 2 of them, plus the 12 plus, which is the mass of carbon, plus 16 times 3, okay, because 16 is the mass of carbon. No, it's not, it's 12. 12 is the mass of carbon. So I'm going to just scribble that out and put that in again. I was right first time. It is 16. 16 times 3, because 16 is the mass of oxygen and there are 3 of them. And if we put that through our calculator, or if you're a mathematical wizard, you'd be able to work out that that's 106 grams per mole. So this is the MR of sodium carbonate. So if we transfer this value into our triangle, okay, 106. And again, if we apply the magic of the formula triangle, if we wanted to know the mass, we would cover that up, the mass, and that tells us to multiply 106 by 0.05. And if you do that on your calculator, you will find that that is 5.3 tons. Okay, so that question asked us to calculate the mass of sodium carbonate that could be obtained from 8.4 tons of sodium hydrogen carbonate. Therefore, it's 5.3 tons. So 8.4 tons of sodium hydrogen carbonate can create 5.3 tons of sodium carbonate. Okay, now I added an extra little bit to the end of the question, which is another new feature. The factory actually made 4.9 tons from the 8.4. What is the percentage yield? Now, I've actually been to a Solvay process factory, and I can well believe that they don't make as much as they should, because the factory is very, very, what's the word I'm looking for? It's not dirty, but it's covered in crusty bits of sodium carbonate, sodium hydrogen carbonate, and the leaks all over the place. Okay, so it's not surprising they don't make the maximum yield. Okay, so yield is the amount you do make compared to how much you should make. And most chemical factories, one of the main driving forces is to try and increase yield to the maximum. Okay, and you are expected to be able to calculate this. So if you think about it, okay, I'll move a piece of paper up. It's a percentage, okay, so we should be making 5.3 tons. That's the theoretical yield. That's how much should be made, but we only actually make 4.9 tons. So the percentage yield is 4.9 tons divided by 5.3 tons, because that's, so this is the actual and this is the theoretical. That's what you should make in an ideal world. And then we multiply that by 100. So if we do that, 4.9 divided by 5.3 gives us 92.5%. Okay, so 92.5%. And in actual fact, as these values here are only to two significant figures, then we should really round that up to 93%. Actually, that's quite high. Okay, right. So that's a percentage yield calculation. So you simply divide what you actually get in the real world by what you could get if this was a perfect reaction, and times it by 100, and you'll know you've got a potentially correct answer if you've got a yield of less than 100%. Okay.